Good morning, everyone. Welcome to today's webinar. We are thrilled to have you join us for this insightful and crucial discussion on PFOS and PFAS and its impact on public water systems. Our topic today addresses what we believe to be a pressing issue that has captured the attention of environmental scientists, public health officials, water management professionals, and now the media. PFOS and PFAS are a group of man-made chemicals, also known as forever chemicals, that have been widely used in various industrial applications and consumer products for decades. From nonstick cookware and water-repellent clothing to firefighting foam and food packaging, these chemicals have been integrated into our daily lives. However, the persistence in the environment and resistance to breaking down have led to significant concerns. In recent years, research has shown that PFOS and PFAS have made their way to our water, posing potential risks to public health and the environment. As risk professionals for public water systems, it is our responsibility to understand these contaminants and potential measures we can implement to mitigate this risk. During today's session, we will delve into history and complexities of PFAS and PFAS, the challenges they present in terms of detection and removal, and regulatory landscape that keeps evolving to address these issues. Before we proceed, I would like to extend a warm thank you to our distinguished speakers for their participation, and to all of you for taking time to join us. Our first speaker is Willis Hahn. Willis is a partner in the water practice group of Nossaman LLP, based in the San Francisco office. Willis represents water industry clients across California on a broad range of administrative and regulatory matters. He has extensive experience before the California Public Utilities Commission, the State Water Resource Control Board, regional water boards, and other administrative agencies. He has also assisted clients participating in the legislative process in California and advised them on new legislating impacting the water industry. Willis holds a bachelor's degree from UC Berkeley and a law degree from Columbia Law School. Our second speaker is Roseanne Weston. She's a licensed engineer and serves as a Yorba Linda Water District's engineering manager. As a head of the engineering department, she is responsible for managing the planning, design, and construction of water and wastewater facility. Roseanne received her bachelor's and master's degrees in civil engineering from Cal State Long Beach and University of Tennessee. Thank you very much, and let's begin our session.
Great, thank you so much, Vlad. I'm really pleased to be here today. This is a really hot topic in the industry and one that a lot of people are thinking about these days. If you can see my screen here. As Vlad mentioned, I'm here to give a regulatory overview of what's been going on with PFOS. I'm planning to start by just at this point, I'm assuming a lot of the folks in the water industry have heard of PFOS, so I'll just quickly provide a background. I'm going to talk about some of the regulatory developments in California leading up to this year, and then the bulk of my presentation is going to be on two recent developments by the U.S. Environmental Protection Agency. That's the National Primary Drinking Water Regulation, or the MCLs you've probably heard about, as well as the designation of PFAS as hazardous waste under CERCLA. And so, as Vlad mentioned, PFAS are per- and polyfluoroalkyl substances, and these are a family of chemicals that are used in a wide range of products. And as Vlad noted, these are man-made, so they're not naturally occurring. There's over 5,000 types of PFAS, some of which are more widely used and studied than others. And the main attribute of them is that they have a hydrophilic functional head and a hydrophobic tail. And so there's a lot of applications for these in consumer products and industry and that you've seen. And so it's a major issue for the water industry for two reasons. The first, as Vlad hinted at, is that there's these compounds are persistent in the environment. They have high temperature stability, they're resistant to biodegradation, they're bioaccumulative, and it's soluble in water. And you see on the slide here that's been found in the blood of nearly every person that they've tested in several national surveys. And so these are great in products so they don't break down, but the consequence of that is that they remain in the environment. At the same
Willis,
time, there's also
sorry to interrupt. We're only have the cover slide. If you don't mind going into presentation and catching us up to the slide.
Yeah. Can you see the
Thank you.
slide now? Here you go. And as I was saying, there's also harmful health effects that have been linked to PFAS as well. And so you have this persistence in the environment and harmful human health impacts. And so what has California been doing about PFAS? This issue has been on the radar for regulators in the state for a number of years now. And so let me just quickly provide a background on how the state regulates different contaminants in drinking water really briefly before I get into some of the more specific regulations for PFAS. So the State Water Board has a series of different actions they can take on contaminants, one of which is the notification level. So this is the concentration of the contaminant in drinking water that the department has determined does not pose a significant health risk, but warrants notification of the public. The next one is the response level, where the concentration is now high enough that they recommend additional steps beyond notification to reduce public exposure to the contaminant. Both of the notification response levels are more for public knowledge rather than enforceable standards where the water agency will have any liability. The next one is a public health goal, and this is the level of the contaminant in drinking water that does not pose a significant health risk to lifetime uses of tap water. So this is a science-based standard that they determine this is the level where people can be safe. It's not an enforceable standard directly, but it feeds into the next item, which is the maximum contaminant level at MCL. And this is the enforceable health protective drinking water standard that must be met by public water systems. And so that's a mix of trying to get as close to that public health goal as possible while taking into account things like costs of treatment and economic factors, things like that. And so since in 2019, the state adopted AB 756. This was a law that directed the State Water Resource Control Board to have the ability to require water systems to monitor for PFAS, as well as setting forth specific public notice requirements that are for PFAS substances. And so you see on the slide here that the current notification levels and response levels have been set relatively low for PFOA, PFOS, PFBS, and PFHXS here. So what does this mean? So as many of the water agencies here have known for a few years now, when you're below the notification level, the only requirements are to submit those results to the State Water Board and report on them in the annual Consumer Confidence Report. Once you get above the notification level, but before the response level, there's a duty to notify for wholesalers, either the governing board or the systems that are directly supplied, or for a retail water system, the governing board and any local agency that's supplied by that water. And so this is public in the sense that it's going to the governing board or other associated water systems, but it's not necessarily going to consumers directly. The third stage here is once you get above the response level, the law requires that you take the water source where detected levels exceed the response level out of use, or you can provide public notifications within 30 days to confirm detection. You also must report that in the annual Consumer Confidence Report. The practice I've seen is once you get above the response level, it's oftentimes water agencies will just take it out of circulation. So you're dealing with the pretty difficult PR situation if you're continuing to provide the water knowing that's above the response level. In terms of the public health goal and MCL, this earlier this year, the Office of Environmental Health Hazard Assessment, OEHA, took the step of adopting the public health goal for PFOA and PFOS here in drinking water. And again, this, as a reminder, this is a science-based level that dictates what level you can be at without posing a significant health risk for lifetime uses of tap water. And so the public health goals adopted by the state here were 0.007 parts per trillion for PFOA and 1 part per trillion for PFOS. The next step for the state would be to adopt the maximum contaminant levels. And so again, you're not only considering the health risk from the public health goal, but you're also considering factors like detectability, treatability, and the costs. And so the goal is to establish it as close as possible to the public health goal, as economically feasible while protecting public health. And the requirement here is for MCLs is that the state cannot set an MCL that's less protective of human health than a federal level. And so the federal EPA sets the floor, if you will, but the states can apply more stringent MCLs, but they cannot adopt less stringent MCLs than what's at the federal level. And that's kind of a segue into the next topic I'm going to be talking about, which is the PFAS National Primary Drinking Water Regulation. So this April, the EPA announced the MCLs for 6 PFAS substances: PFOA, PFOS, PFHX, the Gen X chemicals, PF, and there's a lot of acronyms here, as well as for a mixture of 2 or more of some of these compounds. And so you see on the slide here that they've established both a maximum contaminant level goal, which is equivalent to the public health goal, as well as the MCLs, which are at 4 parts per trillion for some of these, 10 parts per trillion for others. And then they set forth this kind of new hazard index for mixtures of them. One of the departures from what was originally proposed is that they have a longer implementation period that was adopted. And so within the first 3 years, they anticipate this initial monitoring that you either need to go out and test for PFAS if you haven't done so previously, or you have to point to previous testing that had been done. And so the results from that initial testing dictate what has to go on for the ongoing regular monitoring. If if you're under a certain level, it's as simple as triennial sampling, so once every 3 years. But if you're above a certain threshold, then it's quarterly monitoring as the default. So beginning in 2027, the results of the initial monitoring have to be included publicly in annual consumer confidence reports. The regular monitoring begins, and you have to report the results of that as well. And this is an important part here. Once you exceed the MCLs, those exceedances need to be reported publicly as well. But during this period, the MCL is not yet enforceable by the agency. However, starting in 2029, this is the period when now the water agencies need to be complying with all MCLs. And so there's a whole enforcement regime for that, as well as requiring public notifications for violations. Some important things to know here that the regulations here don't dictate how you need to remove the compounds. There's a variety of proven treatment options you can apply, and I'm sure that Roseanne will get into that. Like I said, there's different treatments that exist, and in some cases, it's possible to close out contaminated water sources or obtain new sources as well. One of the things I wanted to know here is that there have been challenges made to this regulation. There's been 2 notable ones one is brought by the American Water Works Association of Metropolitan Water Agencies. The other is from the industry side, the manufacturing industry side, from the National Association of Manufacturers and the American Chemistry Council. And so some of the grounds for these challenges are, this new hazard index, which is brand new. The fact that they issued the final rule concurrently with the preliminary determination that they were planning to regulate it. Usually those are 2 separate things. And the cost-benefit analysis in adopting the MCLs. The agency anticipates that the new MCL is going to require $1.5 billion in costs to comply with, but at the same time, it's going to lead to $1.5 billion in benefits and health metrics for people drinking less PFAS in their water. And so this is all to say that, the regulations adopted, there's certain challenges to you're going to need to comply with it. But there's also a lot of uncertainty with these pending lawsuits. And I have to note here that if there's a change in administration in November, this could be pulled back or changed dramatically as well if the Trump administration comes back into power. The next topic I wanted to just briefly touch on is the CERCLA hazardous waste designation here. This also happened in April, and so under under CERCLA, which is also known as the Superfund law, the EPA designated PFOA and PFOS as hazardous substances. And so there's in the press releases from the EPA, they have some direct effects of the rule, such as needing to qualify certain releases by federal agencies. There's certain information federal agencies need to provide when transferring them. DOT has regulations on transporting PFOA and PFOS as hazardous materials here. And certain owners and operators need to provide notice to potentially injured parties. And so this regulation went into effect earlier this month. But I think the critical piece for water agencies to know is some of the indirect effects here. And what I mean by that is for liability here in terms of lawsuits brought under CERCLA for allocating costs. And so as you see in the slide here, this designation enables cost recovery and enforcement authorities to address PFOA and PFOS releases, which allows them to pursue alleged polluters to pay for investigations and cleanup. This is a really big deal in the sector because under CERCLA, there's strict liability, which means you don't need to prove that it was released intentionally. You don't even have to prove that it was released negligently. You just need to prove that it was in fact released by the defendant. There's also joint and several liability. And so if you have a situation where multiple people are contributing to it, you just need to get at least one of them, and they would be held liable for the entire judgment and have to pursue it from other parties that may be at fault. The last piece here is that it's retroactive. And so the way that it's applied, multiple parties could be held liable, including current owners and operations, past owners and operations at the time of release, people who arrange for disposal, and certain other types of transport. So it's strict liability, joint several liability, and retroactive. That's a very dangerous mix here. That said, there are some limitations in terms of the EPA going after some of the water agencies. You're with the MCL, you're going to be needing to take out the PFOS from the drinking water supply. But due to the nature of it, it's not like they go away. They don't break down. That's the whole point of these forever chemicals. So they'll be in the sludge as you take it out, and you're going to need to dispose of them. And so that disposal is what may lead to liability, and that's the big concern. Unfortunately, the regulations don't have an exclusion for liability for water providers that are simply just treating drinking water and getting rid of the sludge here. But for at least the EPA, they concurrently with this designation, they issued this enforcement policy, which indicates that they don't intend to pursue different parties where equitable factors may apply. And one of those is for community water systems. And so, the EPA at least has said that they won't go after water systems. However, that doesn't stop third parties from bringing these CERCLA lawsuits. Lastly, similar to the MCLs, there's been legal challenges to these new rules brought by different industry organizations, and they challenge it on the grounds of retroactive liability, the notice and opportunity to comment on the rule as it was adopted, as well as the EPA's explanation for that determination. And so again, similar to the MCL, it's unclear how this appeal is going to play out, whether that's going to pull back some of the regulation or not. And again, if with the new administration, they could also have significant changes as well. And so it's a brave new world. There's a whole lot of stuff going on this year for PFAS. It'll be really interesting to hear and see what people are doing to respond to these new regulations in the coming years as they roll out. So that with that, I want to hand it off to Roseanne to talk about some of the experiences that her district are dealing with. Thank you.
Hello, everyone. Get my PowerPoint up. Can everybody see my PowerPoint?
Yes, thank you.
Wonderful. Well, it's my pleasure to be here. Good morning, and thank you, Willis. So, I'm the engineering manager at Yorba Linda Water District. We've been working on this issue with PFAS for quite a while, but first I want to start with telling you about our district. So we're Special County Water District, and we serve the areas of Yorba Linda, parts of Brea, Placentia, Anaheim, and unincorporated county of Orange. We are not too far away from Disneyland, if that gives you a point in our district. So our district is very hilly. We have 19 pressure zones. So we pump groundwater from about 200 feet up to 1,390 feet. And we have two sources of water. We have the treated surface water, and that's imported from the Colorado River and the State Water Project, and that's treated at the Metropolitan Deemer plant in Yorba Linda. And so our groundwater comes from the Orange County groundwater basin. So most of our water that we serve now is groundwater, 85%, and 15% treated imported water per year. But we have the ability to serve 100% groundwater and 100% imported water. So we also provide water and sewer services, and these are our facilities that we have, including our 25 MGD PFAS water treatment plant that I'm going to be telling you more about shortly. But before I start there, I just want to tell you about our Orange County groundwater basin. So Orange County Water District does a tremendous job in managing, protecting this basin. It's very large. Right now, we're very fortunate. It's full of water. And so 19 water retailers, or we call ourselves producers, pump out of this groundwater basin. And Orange County Water District, they have the GWRS. It's a groundwater replenishment system. So they replenish the basin. They also sometimes put met water into it. And in addition, they move water from the Santa Ana River, which comes from the Prado Dam, and they move that water into recharge basins. And that is, our facility is located very much close to the recharge basins and the Santa Ana River, and that's mostly our water. So we've been following this a long time. I've been here 6 years, and ever since I started, we've been following PFAS and putting in place plans. So 10 retailers initially were affected by PFAS. Our wells were very concerned, notification levels, and then response levels came. And before hitting those response levels, a lot of us turned off our wells voluntarily. We turned off 10 of our wells, all wells, and we went right to imported water. Well, nowadays, 15 water retailers are impacted. That's over 100 wells and could be more in the future due to the MCLs. So with pumping of the groundwater down, people turn to treated imported water like we did. And for us, it was something like an additional $27,000 per day for the treated imported water. And so we had to go to putting in place a special fee for our customers to help mitigate those costs, not completely pay for those costs. And then we partnered along with the other water retailers together to try to address this problem because pumping was down a third. And that is initially. And so that was a significant impact for the water district, Orange County Water District, because they had just finished their groundwater replenishment system and they were actually increasing capacity. And so we had a pretty full basin. And so we meet once a month, and we went to twice a month meetings with all of the retail partners in OCWD. And OCWD brought in our state regulator, and we started learning together and coordinating and advocating for all of us. And that was very helpful to bring the regulators in at the beginning. And so we entered into agreement with OCWD that they would pre-fund the design and construction of the treatment plants and also pay 50% of the O&M costs. And the treatment plants, we looked at a 30-year horizon. So that was wonderful. And so they had on-calls for design, and we were assigned Tetra Tech to help us with the design of our treatment plant. And everybody else was assigned one of the on-call design engineers. They also did some preliminary studies. And they put in place these resin refill contracts, and that included disposal. And OCWD does all our sampling and monitoring and reporting to the state. And they also wanted to speed up the construction, so they pre-purchased the filters. And these are the resin filters. And they also pre-purchased some GAC filters for some folks. They also put in place one of the largest, and it's an award-winning PFAS pilot test plant. And this is where they continue to test different media on our water. And this would include resins, GAC, and other adsorbents. And that's been very, very helpful in getting the buy-in and permitting from the state. So the $1.8 billion cost is probably low, but that gives you an idea of the cost for treatment for these treatment plants that everybody's building. So we looked at various treatment technologies for ourselves, and we quickly ruled out membranes because very, very expensive, brine lines, all sorts of issues with that. We toured many different plants and talked to people who had systems in place to treat other things. And it just so happened, of course, that ion exchange and GAC take out PFAS. So we end up going with ion exchange for our treatment plant. And the reason is because we'd have a smaller footprint, fewer vessels would be needed. The height of them would be smaller with the ion exchange. And we were concerned about removing some of the short chains, and we heard that the ion exchange did a better job. Plus, we wanted to, as we say, limit our footprint for our treatment plant, and GAC requires a backwash. And even before OCWD did their pilot plant, we thought we were going to have to build our own plant. So we piloted our water specifically, and we had our own pilot, and we tested 3 resins. So these are the 3 resins that we tested, and they did very, very well. This was actually a 4-month study. We were able to cut it down, and if I can also answer questions on that later. But we wanted to make sure our particular water, which is different maybe from someone else's water in the basin, would do well with these resins. And again, this helped us with permitting with the state. And then we looked at, do we need on-site treatment at our wells? We had some wells at our headquarters, and then we had other wells near the recharge basins nearby, all within a mile. And so the best option is giving up part of our parking space so that we could have our treatment plant right there in front of in our backyard of our headquarters. And it just happened to fit very nicely. People weren't happy about losing parking space, but it was a good option because frankly, our operators were right there. And if there were any kind of issues, they could run out and take care of it, even though it's an automated system. And I'll go into that a little bit more. But it's just better because by having it here, we're very fortunate that our water from the off-site wells and the water from the on-site wells could all be brought to the headquarters fairly inexpensively. So that's why we chose this location. This is our headquarters. And as you can see, I'll just kind of go through the components. On the far left, you see our pre-filters. These are 6 pre-filters, and they're 5 MGD each, so we have 1 spare. We have 22 vessels or 11 lead lag trains. These are ion exchange, and we're able to treat up to 25 MGD, although we're permitted right now for 19 MGD. If we go higher to 25 MGD, we are going to have to get new certifications for our staff who operate the plant. Right now it's a T3, it would become a T5. And then just right after that, we have a booster pump station, which we needed because the wells go directly to the pre-filters, which go through the vessels. But then we have to boost the flow up to our one of our reservoirs. And from there, it's distributed through the system. So as we're going through the design and the construction, we thought, look, we're going to be disturbing our headquarters. So what other things do we want to do now and add to the construction project? And OCWD was very amenable to us adding other things at the time, since we're tearing up our headquarters. And in addition to the upper left, which is our booster pump station, and then and the lower photo there, you know, that was a 25 MGD booster pump station. So those are, we had 5 vertical turbine pumps, and we added a 6th one for a backup. We also added new chlorination facilities because our chlorination facilities needed replacement. It was at the end of its useful life. We did add a backup generator just for the treatment plant. That was a 1,000 kilowatt generator. And we added a 2nd generator so we could back up our headquarters. So as you can see, the agreements with OCWD started in 2019, and then they immediately hired these consultants, and our design was completed in 9 months, and this is over COVID. Same with the construction, about another 9 months, and we got the treatment plant permitted, and we started serving water in December of 2021. So tremendous job. Now, the plant at the time, plus the other improvements I mentioned, were $28 million. And I'm not going to go into the O&M costs because they are ever increasing, but that's something regarding the lawsuit, and I'm not going to go into that. So how has the plant been performing? Well, it's been great, I can tell you. We're very pleased with it. And so we've been doing monitoring, we've been reporting, it meets all the state requirements, it meets the new MCLs, and it doesn't remove all of the PFAS, but all the regulated PFAS. And so we're very pleased with it. If something else comes down the pike and we have to add treatment, we do have space to add, if we had to add RO or something else, we do have space to do that. So we have thought ahead about that. And as I said, the plant is automated, and one of the interesting things is we have very low flows during the winter. And so our flows can be as low as 8 MGD and as high as 25 MGD. And so having all the vessels and the treatment plant at this location, we're able to do that without taking the vessels offline for more than 24 hours. So what we do is we're able to refresh every vessel that may not be in full operation. So when we have very high peak flows, we're operating all the vessels at one time. And one of the things we noted is that the resin is lasting a lot longer than the pilot studies both suggest. So that is very good news because resin is extremely expensive. Our cost is right now to refill resin for one vessel is about $166,000, and that includes disposable. But we anticipate that that cost will go up. And we've had to change out 4 lead vessels and take out the resin, haul that off. And that's pretty good, you know, for the way the plant's operating. So where does that resin go? Well, it's collected. The OCWD has a contract with Evoqua, and they have a provider that they take it to Utah, and they incinerate it. And so one of the things we noted is we have high manganese, and so it's capturing pretty much all the manganese. At the compliance point, which is at the end of the vessels before chlorination, we are practically non-detect for manganese. And that's good news and bad news, because what it means is the resin, it impacts the resin life and it doesn't last as long. But we found a way, and the state has approved, that we can basically scrape off the top layer of the lead vessels of resin, which includes manganese, and then the flow will continue to percolate through the vessels and we can continue using the vessels. The only drawback is the state won't allow us to send the same amount of flow through the vessels as a full vessel. So that concludes my presentation, and thank you very much.
Thank you, Roseanne. We'll move on to the question and answer portion of the presentation. I will start off. Roseanne, that question for you. How does your district dispose of the PFAS that's removed from the water?
Okay, so since it's ion exchange, as we mentioned, what happens right now is Evoca's provider comes and takes the resin out, and they actually put it in super sacks, and that's stored on site. And then when there are enough super sacks, then they haul those off and they take it to Utah to incinerate. And that works right now. We may have to modify that procedure, obviously, with the new regulatory requirements.
Thank you.
Yeah, let me just chime in there on that piece. One of the, Roseanne's mentioning that with the regulatory changes that are happening. So CERCLA deals with when the PFOS is released to the environment. So if it doesn't, for some reason, doesn't make it to that site, or there's a spill somewhere along the way, that's when it might come in. But the other part that I didn't mention in the presentation that's still pending is the potential listing of PFOS as a hazardous substance under RCRA, which is the Resource Conservation Recovery Act. So CERCLA deals with it, once it's already out there and what the liability is. RCRA deals with the situation of what the requirements are during transport and disposal. So to the extent, EPA's proposed listing PFOS as a hazardous substance under RCRA, that's a pending rule. It hasn't been, the final rule has not yet been adopted, but once it is, that might raise different requirements for how you're transporting it, what sort of manifests need to be required, different requirements for transporters. So that's kind of the other, CERCLA is one shoe. We're waiting for the other shoe to drop.
Another question for you, Willis. How can we, the collective individual agencies, address the upcoming PFAS regulation? And are there any wastewater associations that are trying to address the regulations surrounding this upcoming legislation?
Well, it's been a large effort during this rulemaking process to get out ahead of it. A lot of the national associations that represent water providers were providing input throughout the process to EPA on, maybe there should be a carve out or exemption for water providers that are just providing, that are just taking out PFOS as part of the treatment for public drinking water. That unfortunately that was never adopted by EPA, and so I think it's turned to two places. One is the legal challenges brought by those associations, but there's also legislation that's being pursued that would provide the legislative fix to that, if you will. And so there's efforts at the national level for different entities that want to push those kinds of things, but that's what's been going on.
And it looks like a follow-up question. Do you anticipate class action litigation organized against public water systems, or do you see the PRPs being in the line of sight due to deep pockets and easier causation?
It's hard to say. I mean, I feel like if there's with CERCLA, that's the mantra is often for plaintiffs to just sue everyone and anyone, get the money, and then let let the people in the right go after the people in the wrong. And so unfortunately that's often the reality. You know, as a practical matter though, it's it, it's really not good publicity to go after, someone that's just cleaning up the water. Hopefully there'll be a fix to that. But it's like I said, it's hard to say. It's hard to predict what lawsuits might be brought. I, I mean, in terms of a class action, it's against water providers. It's a little bit difficult, and I don't think it would fit under CERCLA. The reason is you need to, even though it's not strict, even though there is strict liability, so you don't need to show negligence, you don't need to show uh, intentional acts here. You still need to prove that the PFOS was released to the environment due to some action by the water provider, and that can't be a unilateral thing. It has to be proved on a case-by-case basis. So that I think that's the primary reason why I don't think a class action is likely here.
I would like to add that one thing I think is very important is communicating with your constituents. And we've OCWD and other water providers in our district, including Yorba Linda Water District, has been out front on all of this, just explaining what we're doing to address the problem, the design, the construction, the results. So we've been, and in addition, we have participated in UCI's water quality panel where they were testing the blood serum of people in our water district. We said, yes, please open it up to our water district so that our customers, if they would like their blood serum tested, and we've had participation. So we're trying to address the problem. We're right there with them, trying to provide safe drinking water. So I think that's very important.
And Roseanne, can you speak to the community outreach by your district to confirm that the PFAS treatment removes health concerns in its consumption? And do you have any suggestions or best practices for the group to consider?
Well, of course, you can look at our water district website, and we have information, and we point to a lot of that, and we highlight all the work that we've done there. And if you go to OCWD's website, you'll see they put a lot of their information. In fact, they tend to prepare a lot of the information that we do also use when it just is regarding the entire basin. And we participate whenever we can with advocating and making sure people know that we're advocating on their behalf. So I think just check out our website and you'll gain a lot of insight. And I'd be happy to answer questions later if someone wants to contact me.
And just to quickly add on that, the whole like how to communicate PFAS to the public is the major challenge here. This is a pretty complex scientific thing. Just the name itself sounds very scary. And so, in addition to the stuff that Roseanne has and that OCWD has, there's also toolkits that the state has provided. If you go to the State Water Board website, there's a media toolkit, I believe, there that helps, for the water agency specifically to communicate to your customers what's the problem, what's the risk, so that they're informed, and what we're doing about it. And so I think that's a big piece of it. EPA also has media toolkits. It's just the communications issue of PFAS could be its own webinar here, really.
Yeah, I agree. And it's not just putting it on your website, it's reaching out. So we use several social media platforms to get that message out. We also communicate with the cities that we serve and so they can also communicate. And we go to meetings everywhere where we think we could spread the word.
Roseanne, I have also a quick follow-up question. Out of the three substances that you used, the three resins, what was the most effective one?
So PSR2 Plus that's a Evoqua product. Well, strangely enough, it's a DuPont product, which say no more. It has been the most effective in reducing the PFAS in our water, or I should say eliminating or going to non-detect on the things that are regulated or below the levels required. So that one has performed the best. And I would say one lesson learned is we were asked by OCWD if we could pilot another resin, and it didn't perform as well. And the reason why, I'm not saying it's a bad resin, it's just that when you have two different resins in your treatment plant, then you can have some pressure imbalances. It can be difficult to balance the flows because one has greater head loss than the other. And so we learned from that, and we've since replaced that particular train with that resin with all the same resin and PSR2 plus, and it's lasting a long time. So if something else comes out that'll do a better job, we'd be happy to switch over. And we've been in discussions with OCWD. They have their pilot plant nearby, and the plan is to move it to our facility because we're participating in their WRF study, which they have bench scale testing, and they want to compare that to full scale testing. And they also have this pilot plant. So it'll be very interesting to see how things perform. And the whole point is that this will benefit other people if they find a way to reduce the amount of time it takes to test water, because testing water with a certain product is very important as required for permitting with the state. And initially it took a year to pilot it, but now we're down to, hey, maybe we could reduce that to 2 months.
And Roseanne, is your agency as well as Orange County, are they sharing this information with other public agencies and inviting cooperation from other public agencies to participate in some of the testing and maybe benchmarking of different methods of removing and disposing of PFAS?
Yes, absolutely. For full-scale testing, and I don't recall which ones they are, but yes, in Southern California, they've reached out to other agencies to do some full-scale testing at their plants and compare that to the bench scale testing. And you would
Okay.
have to contact OCWD for more information, but I believe it's on their website.
Okay. Yeah, if it would be great to share with our members, so maybe we'll do some research and post it on the Water Leadership Group website under resources. For those of you who are interested in sharing the information and maybe participating in some of the testing for your respective water agencies, we'll share that information on our website so that you could take a look at it and hopefully work cooperatively with the leading agencies to try and get that organized as well. Okay, great. Chris, do we have any additional questions?
I don't see any at this time, no.
Okay,
I would just like to add something. I mentioned how OCWD managing the groundwater basin stepped in, and I just think that's something that other groundwater basin managers should consider if they're not already, because they may have producers or pumpers or retailers, whatever they may call them, that don't have the means to put treatment in place. And OCWD was able to get funding, grants. They were able to get WIFIA funding. They had the reserves and other means to go ahead and fast track some of these projects. And we all pay for it, right? We all pay over time, but it is financially acceptable to pay for a longer period of time for these things. So we minimize the impact on our ratepayers. The other thing to consider is that's lost revenue for the groundwater manager, because, if people are not pumping a lot and they have water in the basin, that has a financial impact on the groundwater basin manager. So.
Great. Thank you so much for this information. As I mentioned, we'll be sharing additional information as well as the recording of this video on the Water Leadership Group website. If you are new or you're a guest at today's presentation, please feel free to reach out to me or any of the members of the steering committee, and we'll be happy to share additional information with you. Willis and Roseanne, first of all, thank you so much for your expertise and for this very insightful presentation. This was very, very useful. I know that for many risk professionals that I discussed this with, as you know, the worst enemy of any risk professional is uncertainty. And Willis, as you referred to it, it's definitely a brave new world out there, but sometimes it can be very scary for risk professionals because of uncertainty. I have heard PFOS and PFAS being referred to as the new asbestos. So there's definitely a lot of unease and uncertainty among the risk professionals as to what's going to happen. Are we going to face lawsuits or class actions, lawsuits from, crafty people that we have faced them from before in other areas? And we are definitely just starting to explore this subject. The Water Leadership Group is going to be discussing this further in our open forum session in August. So we'd like to invite everyone to bring their questions and concerns about PFAS and PFAS to that session. And also, just to let you know, we're planning to present part 2 on PFAS and PFAS in the month of September. That particular session will concentrate on the issues related to insurance coverage. And not to scare anyone off, but if you haven't seen a specific exclusion in your excess liability policy this year, then you either did not read it very accurately or it is still coming. But most excess liability carriers have added that as a standard exclusion from your policy. So we'll be talking about that. We will also be talking about cost recovery if you do receive a claim or a lawsuit related to PFAS. And then lastly, but I think this is a very fascinating subject to me, we are planning to bring an insurance archaeologist who assists agencies in looking for legacy insurance policies where you may have had coverage for these substances, or you may be able to trigger a policy for defense obligations and helping your agency to cover the cost of defense. So this is all coming up in the next couple of months, and we would like you to stay tuned and attend the August open forum session as well as our September presentation. And we're looking forward to seeing you next month. I just want to thank again Roseanne and Willis for their very insightful presentation, and I want to thank all of you for joining us today. Thank you very much, and have a great rest of your day.
Thank you.
Thank you, everyone.
Bye.
Thank you.